With a story that stretches back millions of years, this ancient titan will challenge everything you thought you knew about the reptilian realm. Just when you thought snakes couldn't get any scarier, this prehistoric predator slithers its way into the spotlight, boasting a size and strength that will leave you in awe and terror. From its bone-crushing squeeze to its insatiable hunger, this is a creature straight out of a horror movie. Brace yourself for an encounter with the Titanoboa, a true embodiment of nature's most fearsome and extraordinary creations. Titanoboa is an extinct snake that lived during the Paleocene epoch, which was 66 million to 56 million years ago, considered to be the largest known member of the suborder Serpentis. Titanoboa is known from several fossils that have been dated from 58 million to 60 million years ago. From extrapolations of body size made from excavated vertebrae, paleontologists have estimated that the body length of the average adult Titanoboa was roughly 13 meters, and the average weight was about 1,135 kilograms. Titanoboa is related to living anacondas and boas, but it is uncertain whether it was more closely related to one or another of these modern constrictor snakes. Titanoboa was first described in 2009, some 5 years after it was excavated from rocks exposed at the Cerrejón coal mine in Colombia, which lies to the west of the mouth of Lake Maracaibo. The remains of approximately 30 individuals have been recovered. The majority are adults, but some juveniles have been found. Most specimens are made up of vertebrae and ribs, which is typical of snake fossils. It is estimated that Titanoboa may have had more than 250 vertebrae. At least one nearly complete specimen with a skull has been recovered. The presence of such a large number of individuals displaying the same gigantic proportions demonstrates that 13-meter lengths were probably the norm for adults of this species. By comparison, adult anacondas average about 6.5 meters in length, whereas record-breaking anacondas are about 9 meters long. No living snake has ever been found with a verified length in excess of 9.6 meters. The snake's enormous size is thought to be closely tied to the climate of the Paleocene. Snakes, similar to other poikilothermic or cold-blooded animals, have metabolic rates that are influenced by the temperature of the ambient environment. To maintain normal growth, snakes must have the proper amount of warmth. A snake would need an exceptionally warm environment, such as the one that characterized the Paleocene, to grow as large as Titanoboa. Thermoregulation can be defined as the process of regulation of the body temperature according to the environment. Since Titanoboa is considered the largest snake, a member of the Reptilia family, it is thought they are ectothermic. Exothermic organisms can be defined as the organism which regulates the temperature of the body by utilizing the environmental temperature. They do not have internal thermoregulation physiology, which is based on the metabolic process. Titanoboa is also considered to be poikilotherms. These can be defined as cold-blooded organism. The thermoregulation of the Titanoboa information links the evolutionary details to the climate of the Earth during that period. This is important to take into consideration because the enormous size of the creature can be explained by this correlation. As the Titanoboa is considered to be poikilotherms, they need external environmental heat to maintain the growth rate and the proper functioning of the body. Since they are very large, the biggest Titanoboa can range up to 42 feet. They would have needed enough environmental, which suggests that the time period during which they lived was about 55 to 60 million years ago in the Paleocene era. The Paleocene era has the significant characteristics of high environmental temperature, supporting the claim of survival of such extraordinary creatures during this time. The coals mined at Cerrejón are formed from deposits left by an extensive Paleocene swamp situated along the margins of an ancient shallow sea, which sat at the base of the early precursors of the Andes Mountains. This ancient environment had been similar in composition to the swamps of the Mississippi River Delta or Everglades in North America. However, it was situated in the tropics at a time when Earth's climate was exceptionally warm. Since the Titanoboa are classified as reptiles, it is believed that they followed sexual reproduction. They followed internal fertilization common to reptiles. Much about the reproduction pattern of the Titanoboa is still not known. Another interesting fact about Titanoboa is that they are classified as amniotes. The amniotes are the organism that has a protective covering around the egg or embryo. The protective covering is commonly known as the amnion. Since all snakes generally reproduce by laying eggs, it is the same for the Titanoboa, but whether they lay eggs and provide parental care, or the eggs are carried by females inside their bodies until they are hatched as seen in ovoviviparous animals is still unclear. The taxonomical classification and the fossil evidence of the Titanoboa suggest that the organism was related to the present-day anacondas and boas. It is still under debate that which of these animals was more closely related to the extinct Titanoboa snakes. The fact about Titanoboa was the nature of the snake. They were classified as the carnivore. Even with their large size, they are not most widely accepted as an apex predator. It is mainly because of the restricted habitat and comparatively slow speed of the snake against the competitor species. The diet of the Titanoboa mainly included crocodiles. The other animals that were the prey of the Titanoboa included the other snakes like boa constrictors, cobras, pythons, fishes, turtles, and others. The extinction of Titanoboa is still a subject of scientific speculation and ongoing research. While a conclusive explanation is yet to be determined, there are several theories regarding the demise of this colossal snake. One prevailing hypothesis suggests that changes in the Earth's climate played a significant role in the extinction of Titanoboa. During the Paleocene epoch, the planet underwent a period of cooling and drying known as the transition from the Paleocene to the Eocene. This shift in climate resulted in the contraction of the tropical habitats that Titanoboa inhabited. With reduced suitable environments and declining prey populations, the survival and reproduction of Titanoboa became increasingly challenging, potentially leading to its extinction. The shrinking of tropical habitats due to climate change also caused a reduction in available resources and habitats for Titanoboa. Loss of wetland areas and changes in vegetation patterns may have limited the snake's ability to find suitable hunting grounds and reproductive sites. Significant events, such as volcanic eruptions or asteroid impacts, can cause widespread environmental disruptions and mass extinctions. While no direct evidence suggests that such cataclysmic events led to Titanoboa's extinction, these events could have caused cascading effects within ecosystems, altering food webs and disrupting the delicate balance of predator-prey relationships. The resulting ecological upheaval may have had indirect consequences for Titanoboa's survival. As its preferred habitats disappeared or became fragmented, Titanoboa's populations may have declined, eventually leading to their extinction. The Titanoboa share the family with these organisms. All three organisms belong to the same family known as Boida. The members of the Boida family are found across North, Central, and South America, as well as the Caribbean. The other members of this family and living relatives of the Titanoboa are found across the continent of Europe and parts of Asia, Northern, Central and East Africa, Madagascar, the Arabian Peninsula, Central and Southwestern Asia, India and Sri Lanka, the Moluccas, and New Guinea through to Melanesia and Samoa. The unique characteristic common to all the living relatives and Titanoboa is the absence of venom. All the snakes of this family are considered to be non-venomous. The existence of such a monstrous creature reminds us that our planet has been home to extraordinary inhabitants that defy our imagination. The Titanoboa's presence not only challenges our perceptions of snakes, but also ignites a sense of wonder and curiosity about the mysteries that still lie hidden in the depths of our planet's past. If you enjoyed this video, don't forget to hit that like button and subscribe to our channel for more fascinating content about the wonders of the natural world.